very important to have the same standard rules of working, and some of this is pointed in the slide. So how many of you have coding style that you use in your team? Standard coding style? Nobody? All right. And what about, pardon? What about the analysis tools such as Jaslyn and Jasin? Who use that? How about, for example, an active measurement to make sure that the code doesn't regress? So a lot of unit testing, a lot of coverage testing, and so on. All right. So these are some of the steps that a team usually take if you guys want to make sure that the code is consistent and the code is high quality. So if you speak about quality to a lot of engineers, there's a lot of different ways to measure quality, but this is just some of the practical aspects. You don't want to write code that is ambiguous. You don't want to write code that's full of mistakes. And of course, maintainability is also very important because you don't want to have something that you cannot maintain in the near futures. So quality, practical aspects can be manifested in some of these points. So speaking about tools, a lot of people say, a lot of experts say, oh, I don't need an IDE. I can just use my terminal in Vim or whatever editor, and then they're happy with it. This is true to a certain extent, but if you just see my diagrams here, on the left side is the ISO lines of, or the contour lines of the mistake. So the lower one is when you see the skull there, and then the nice one when you don't have any problem is when there's a cat over there. So if your skill is very high, then obviously you make less mistake. And as the application grows in complexity, you start to make mistake, because no matter how perfect you are, at one point you'll break down and then start doing something stupid. But if you're, average engineer, and you just start to learn the language, you're new to the environment, you don't know the API very well, then you tend to start to have some problems, right, even when the application is not very complex. So the purpose of the tools is really to reduce or to change the contour lines to be something on the left side, where if you have a high skill, then all the tools will do is to tell you that, hey, you tend to make this mistake, but now you're fine and you learn from it. And if you're still new to the environment, you can start to have some meaningful coding quality, and you don't need to get trapped in a couple of typical mistakes. So one of my philosophy in testing is something I call multiple layer of defense. So basically, instead of trying to solve all problems at once, you put certain protective layers. And that's typical people develop application, whether it's native or web, right? So for example, before you launch your, how many of you guys here use Selenium for cross-browser extensive testing? Yes. Before you launch your Selenium-based testing, you probably want to see, hey, is my code correct? Does it look okay? And you want to do a lot of smoke testing before you send it to the cloud or to your extensive QA. So with multiple layers, at one point, the goal of the layers in this defense is that the first one should be the cheapest one to do. The first one should be something that's built into your workflow, and then the later stage before you deploy it or before you ship it to the customers is something that's really extensive. I'm going to show some of the examples in this presentation. So people use tools because it's boring, or it's repetitive, or it's time-consuming if you do it by hand. And this two-way feedback cycle is very important, because sometimes or more often the tools give us feedback. So most of the time the tools give you feedback, hey, you should not do that, or your trace breaks. But we also would like to give feedback to the tools, and I'm going to show you why that's important. For example, in some of the tools that can analyze your code quality, the way you adjust the tool is by changing some dials and some knobs, and then make sure that, hey, I want this testing to be done, I want to skip this and this and this. If you use Jaslyn or Jasin, that's the way you customize the behavior of the testing tools, because you want to match it to whatever you have. But there's also another way to improve the tools to suit your workflow, which is you give a sample to the tools and then say, hey, this is what I want, and then make sure you test it to the things that I want. I have an example for that. So in my opinion, the state of our JavaScript tools right now is like a spelling checker. So if you see the sentence, nothing is wrong with respect to the spelling, but grammatically it doesn't really make sense. And this is something that we need to fix in the next year, 2013. So the tools need to have a much richer understanding of your semantics, a much richer understanding of your program. As an example, if you see this simple snippet of Backbone, You define a new road, or router, but because of a typo there, it won't work at runtime. This is something that typical static analysis these days cannot understand because it doesn't have the understanding of the convention that you use in your application or your framework. So because JavaScript is very dynamic, you can do whatever you want. Somebody can do something behind your back. It's also very important to bolt in some of the convention rules. Now, of course, some of you might say, but it will not catch all the problems. That doesn't matter because of the multiple layer defense. So you want to have a first layer of sanity check that sort of catch all the most cases, all the most common problems that a team usually make. So some of the basics before we go into a nice analysis. So when JavaScript runs in the browser, JavaScript engine is just one of the components. You would know about, the rendering engine itself, such as WebKit and Gecko, and they're responsible for taking the contents of the web page and then the style and so on, and then create something that shows to the screen, basically pixels on your monitor. And there's also networking, obviously, because you need to fetch data off the remote server. And if you zoom in, JavaScript engine basically consists of these blocks. So it will consume your code and then parse it. That's responsible for the parser. The outcome of the parser is a syntax tree, and then it will run in something called virtual machine or interpreter. Some of the standard objects, if you use JavaScript, string, math, they are additional. They are runtime objects, and that has to come into the virtual machine as well. Now, if you want to try to understand how your program behaves, obviously you need to implement everything, but if you just want to have a semantic understanding of the program, the parser will be more than enough. So first step of the parser is to break your code into tokens. In these examples, the tokenization stage basically splits down your code so that it knows that, hey, this is a keyword, this is an identifier, this is number, and so on. Once you get that, it will try to build a syntax tree, and this is basically what JavaScript engine also does when it consumes your program. Syntax tree means that it's a tree that represents your syntax. In this case, it's a variable declaration, and then the identifier is so, and then the value is so. Now, once you have the syntax tree of your entire program, you have all the information necessary to understand what the program is trying to do. And of course, if you want to implement a JavaScript parser, one of the strictest requirements is that it has to follow a standard. So it has to understand all the construct that is defined in the ECMAScript specification. How many of you here have ever read ECMAScript specification? It's only 258 pages. Most people don't need to do that because, I mean, you don't learn how to write articles by reading a dictionary or something like that. But it's very important to try to make sure that your code or your parser understand all the construct that is specified in that standards. That includes strict mode, that includes semicolon, automatic semicolon insertion, that also includes Unicode. And in some cases, the syntax tree that's produced by the parser needs to have some sense, so it should not be completely cryptic. One thing that I implement in Esprima is following the parser API that's specified by Mozilla in its JavaScript engine SpiderMonkey. So if you see this very simple line of code, the syntax tree formatted as JSON will look like this. And from this, you can totally understand that, oh, there's an expression there. It declares or it defines a literal 42 and it assigns it to a variable called answer. If you want to try it live, you can go to that URL and then you can paste your code and then it will give you the syntax tree. The nice thing about the syntax tree like this is because it matches the specification, it matches the grammar that's defined in the specification, and the source code looks like that as well. So if we see the specification definition for a while statement, it looks like that, while and then expression in brackets and then statement. And if you write an example program like that and then put it in the parser demo, what will you get is the tree that looks like on the right side. So it's really similar. It's used the same terminologies. And the actual code that parses this while statement looks like this. This is part of the parser. So having all the specification, the parser code, and the syntax tree, they all use the same terminology, really helps because then it's easier to cross-reference all of this. One of the things that very nice with SpiderMonkey Parser API is the location information. So if you create a syntax tree, you can tag location information that correspond to the actual tokens in your source code. So if it's like this, you have the syntax tree from the range field there, 0 to 6. I know that if I want to find that identifier, all I need to do is to go to the original source code, and it will be from location 0 to exclusive 6. And the same with literals and so on. We're going to see why this is very useful. If we try to parse something that is conformant, that's rather possible. However, sometimes you want to build a parser that's suitable for IDE or an editor. And in that case, user makes mistakes. So sometimes you want to have a behavior that I call error tolerant. So if you type using wrong quotes, opening and closing quotes, they don't match, or you put too many dots or stray characters there, or you haven't finished typing, or you do something that doesn't follow the specification. In some cases, the parser needs to be able to cope with the situation and doesn't just bail out and say, oh, your code is completely bogus, I don't want to do it. I don't want to parse it. Comments handling is extremely important for source code. How many of you here generate API source code or application source code through the code annotation? There's like the tools, JSDoc and JSDoc and a lot of other documentation tools that extracts the comments and then probably format it as Markdown and then produce an HTML file that represent what the code is trying to do. So in some cases, contracts can be defined as comments as well because it will be ignored by the JavaScript engine, but you can build tools that analyze that contracts and then see if that contract is fulfilled or not. Forward looking, how many of you here follow ECMAScript 6? That's the next generation of ECMAScript. Right now we're at 4.1. And the new standard will define a lot of construct that can be very beneficial for application developers. Everything from destructuring module classes and block scope and so on. I can talk for another hour about this, but let's just skip that. Code regeneration. If you take your code and then you get the syntax tree and then you regenerate again the code, that's something that called code regenerations. And then a lot of things you can do with this. How many of you here minified your JavaScript before you deploy it? Using what? Closure compiler? And Uglify.js is another popular choice. So what this tool does is take your code and then get the syntax tree and then rewrite it so that during the execution it still behaves the same, but the actual generated source will be smaller than the original one. That's called minification. Sometimes it changes variable name, so instead of very long descriptive variable, it changes it to say A, because for browser and for JavaScript engine, it doesn't really matter how your variable is called as long as it's consistent. And say remove code, because Closure compiler, for example, can remove code that you don't need or you never call. And this is something that is done through code regeneration. Now let's see some of the tools that we can have if we already build some of the foundation. So I usually categorize all the tools into 4 groups: code inspection, and then static analysis, dynamic analysis, and then kind of code transformation. Let's see the first thing, inspection. So obviously what you can do is when you have code, plug it into this parser demo, you'll get the syntax tree. So for this particular example, maybe it's obvious, right? Even without seeing the syntax tree, you kind of understand what this code is trying to do. But in some cases, there are like cryptic code that why it will return 10 in this case. And then, of course, you can just run it in your browser or console or Node.js or whatever, JavaScript interpreter. But if you want to try to understand what the browser or JavaScript engine understand from this particular constructs, then you can put it in the parser and then see the output. So in this case, apparently, all that curly braces block is just defining a new expression statement that doesn't affect anything. You can also validate the syntax because a faithful parser will tell you if your code is bogus or invalid. So there's a nice demo there. If you want to try live in your browser, you just paste your code and it will tell you what's wrong with your code. So syntax validation can be put in your continuous integration system. How many of you use Jenkins? TeamCity? There's also cruise control, and then Hudson, and etc. So before, like I mentioned in the earlier slide, like multi-layer of defense, before you even deploy your apps or run it through extensive QA, you might want to check whether the syntax is valid or not, because it would be really stupid to try to test some application that is not valid. So a linter is slightly different than a validator. Famous linter is Jaslyn or Jasins, because a linter tries very hard to make sure that you're not doing something stupid, whereas a validator is just, hey, if you pass the validator, then the JavaScript engine will be happy and consume it or execute the code. And sometimes linter is very restrictive in the way you write your code, because if you try to pass a code that is already minified by Uglify.js or Closure Compiler or CoffeeScript, anyone use CoffeeScript here? If you pass generated code to a linter, then most likely it will complain because it doesn't follow a good practice in coding. But that code is totally valid, so it will pass the validator easily, because technically your browser can still understand and execute that code. So there are different use cases. Validator is fantastic if you put it in your development workflow. How many of you here use Git? And use Git Precommit Hook. So Git Precommit Hook is a hook that gets executed before, during your commit. And if it returns non-zero, it blocks your commits from happening. And this is a perfect chance to inject any kind of syntax validation, because if you commit something, if you try to commit something and it doesn't pass the validation, it will just exit with one error code, and there won't be anything committed. Your working directory will be dirty, so nothing will get committed. So you can even prevent bad code to enter your source code repository, because it will be blocked by the pre-commit hook. That's another protective layer in your multi-layer defense. In a typical IDE, whether it's cloud-based or running on a browser from local server, it's possible to get understanding of your code by parsing it and then extracting the information out of the syntax tree. For example, for the case of Eclipse Orion, it will be able to display all the function outline. This is a standard feature in typical smart IDE like WebStorm. And the way it works is really parse your code and then see for function variables, just look for all the function declaration and function expression and deduce the name and then displays there. Anyone here use Eclipse Orion? Yeah, it's basically cloud-based JavaScript editing. You can run it on your browser. So autocomplete is often very useful because then you don't need to memorize or remember all the function names and function variables, because sometimes it's very long. And again, the way it works is if you already have this information, all the variables name or the functions, then it's a matter of trying to match what the user is trying to type with whatever choice available for that particular situation. This is the case where error-tolerant behavior can be really useful, because as seen in my screenshot here, I haven't finished typing anything yet, and that could be just invalid. But the parser needs to see that, hey, the user hasn't finished anything, so it might be invalid, so if something is wrong, just continue or ignore it. This is another editor from VMware/SpringSource called Scripted. Oh, not really visible in the slides, but index there is highlighted, and then I can see all the occurrence of all the variables there. Very useful for code editing, because sometimes you have a function and then you want to search where the function arguments is being used. Live editing. How many of you here have seen Brad Victor's talk about programming? And some of these features have been implemented in Khan Academy Computer Science corner. Have you ever seen live editing of JavaScript code in Khan Academy? That's very impressive. So in this simple project called Scrubby, it's probably easier to demonstrate. So when you type a code here, every literal or every constant will be editable live. So I can just drag this and change the size. I can change the color. This is possible because Scrubby rewrites your application code and changes all the literals to just the variables. And then as you drag the value, it replaces the value of the variables. And then the code runs again, taking the value of the variables. So if you want to experiment with certain prototyping, particularly useful when you draw something, you don't need to keep typing your code and then live reload your browser or do something else. You can also get some nice statistics of how certain particular keywords used in your code. This is not really useful, it's just to give a nice understanding of the distribution of the popular keywords. Apparently, I've done this through 2 major libraries, and it seems that this is the most popular keyword, and then function and if and return. It gives you a nice idea as well. For example, if the number of try and catch they don't match, then something is suspicious there because try is supposed to be followed by catch. Same if case is less than switch, then how does this even happen? So it's probably impossible. You can check also the statement. So most statements, JavaScript statement is typically expression. So you assign the values of some expression to variables. And of course, block statement. You can also see how distributed your identifier variable names. So if it's very high, it means that your code is very long or verbose. For example, the longest identifier that I can find was in prototype 1.7. It was really long, but from many major libraries, apparently the mean of identifier length is about 8 characters. Of course, there are tons of things that you can infer from your code after you get the syntax tree and then analyze everything. So everything from comment density. So you can measure like how many lines of comments compared to how many lines of code, because if it's like 0, then your code is totally not commented at all. That's kind of scary. So that's the way tools can inspect your code and report something quickly. But there are also something called static analysis. This is the job that is usually carried out by JSLin and JSHin. And code linting is very popular. For example, if your coding style mandates that you should never ever use double equal, you should always use strict equals, then you can do some testing by yourself this way. Because all you need to do is write literally just this 10 lines of code that parse your code and then look for that particular usage of this double equal operator. And then you can display some warning. You can also find Boolean traps. This is one of my favorite API Hall of Shames. Can anyone tell me or guess what will the last line, the first line that means? I mean, false. Why do I want to put false there? Any guess? So apparently a slider component can be horizontal or vertical. So the way you decide it is that if you put true, then it will be this, and you put false, that will be the other way around. I guess it makes sense because you haven't seen any diagonal slider, right? So there can be only 2 choices. It's either true or false. But this is an example of Boolean trap where when you write the code, you can look up at the API docs and see exactly, oh, I want it to be horizontal, and therefore I put true. But when someone reviews your code, or you yourself in 3 months look again at your code and see what is actually false there, you need to search the documentation and see why did I choose false. This is another thing, so especially difficult for a non-native speaker. Why will I say component set hidden false? Why can't I just say set visible true? Or like set, if filter is not case insensitive, does that mean lowercase a equals capital A? You will need a few seconds to realize that, oh, this is actually what it does. So double negative can be filtered because you can scan the code and see some particular keywords that triggers that behavior. These are all taken from real-world examples, so I'm not just making this up. This is one of the biggest offenses. It's like 3 items, state, true or false. What does it mean? Why do I need to pass 2 completely opposite Boolean values there? So if you look at the docs, apparently the first is the actual state, whether it's collapsing or expanding, and the second value defines whether you want it to be animated or not. So in this case, I don't want it to be animated, so that's why I put false. But if someone just stumble upon the code and then see, oh, what is this? It's confusing without looking at the docs. Of course, the biggest offense is still the DOM API, because if anyone can tell me what does true, false that mean? So there's a bunch of Boolean values and variables and other literals that it's impossible to guess what this means unless you look at the documentation. So all of this can be inspected or tracked easily, because it's rather possible to write code that see all this. In fact, you can just use the one that I posted in my blog post. Look for Boolean literal that serve as a function arguments, or look for words that is listed in the blacklist of double negative and so on. Ternary conditionals. How many of you likes to nest all the ternary conditionals, like several steps? Yeah, this is sometimes beautiful, because the example that I've given here is not too bad, because you can totally follow the logic and make sense. If you dump the syntax tree, it looks like this, and you can just detect the use of nested ternary conditional by seeing which node gets which one, so follow either from the child to the top or from the parent to the bottom. So if your coding style mandates that never ever nest more than 2, then you could totally detect that and then give some warnings. Nested ternary conditional is nice, but it's horrible to debug. Strict mode check. How many of you here use strict mode? Always use strict mode, yes. For those who haven't, please do. There's a lot of goodies there. There's a lot of things that strict mode can do to prevent mistakes. And in this case, sometimes you forgot that, hey, I already declare a property name. The name equals to something that you have declared before. In this case, it's not too bad, because it's like 4 lines, but if you write a backbone application and all the way to the end, you define another function, that might just be the same with the one that you declare at the beginning of the source line. So duplicate property is not allowed in strict mode. If you run this code in the browser, it will immediately refuse that. Of course, you can run this through some analysis. So a typo can have a very bad impact. If you use strict mode, this is caught pretty easily, because then you leak to the global. What you declare is not the same as what you use. And you can use very nice command line tools that detects that kind of usage, or that kind of mistakes. Of course, the same mistake has another problem where variable height is not actually used. And again, it's rather tedious to find all these unused variables manually. You might want to use some tools that scans for all variable declaration and see whether it's actually used or not. Code complexity. How many of you are familiar with cyclomatic complexity? So cyclomatic complexity is one of the code metrics that describe how complicated your code is. And in this case, you can use jscomplexity.org. That's an online tool. You can paste your code and it tells you maintainably index and logical line of code. I think in this case, because technically you need to break it down into 4 lines and not put everything in 1 line. And then the complexity. For this case, I believe because it has 4 edges, 4 statements, and then 4 nodes, and then 4 statements, and then you have 1 terminal, because it doesn't go anywhere else. It has to follow through all the branches to the end. So if the number goes high and high every time someone checks in the code, you might want to say, hey, something is wrong there. I don't know anything about maintainable index, so probably look it up in Wikipedia or so. Dynamic analysis. So static analysis works by reading your code and then try to deduce what you're trying to do and then see if that is stupid and then warn you about that. Dynamic analysis is different. Dynamic analysis means that it has to run your code and then see what happens there. So coverage. How many of you here runs your code through code coverage analysis? Not a lot of people. That needs to increase as well. So coverage means you want to find out what part of code is being executed or not. So if you write a complicated code and you write a unit test and the unit test only tests a trivial part of your code or your application, that doesn't really mean anything with respect to the coverage. You want to write code that's tested, or you want to make sure that your tests actually check something important in your code. So one way to do coverage is using instrumentation. So in this case, you can use the node cover project. This is just one of the code coverage out there. So if you run this code, then it will say that, hey, the third line is actually never gets executed because it's a wrong branch there. It's a false branch. And the way it does is it takes your code and then injects additional instrumentation. And then as the browser or whatever JavaScript engine execute the code, it gets to know whether the extra annotation gets executed or not. So statement coverage is very important. Unfortunately, it presents some hidden trap, and it's equally important to see what kind of branches is being executed. I'm just going to skip this. If you want to do branch coverage, there's a nice project from the UI team called Istanbul. And if you see the code, if you just run this through statement coverage, it will say that all those two lines in that function, they are all executed. But if you run it through branch coverage, it will say that, oh, no, that particular if there, the else branch is not executed. And of course, if you write unit tests, you want your test to exercise all possible workflow in your application. Execution tracing. How many of you here use jQuery mobile? So mobile application in general, mobile web? Yep. So mobile is slightly different than desktop because of all the limitation of mobile platform. So it's more important to pay attention to performance there. So one of the metrics that you can get if you annotate all your function is how many function calls are being executed if you do something. For example, if you start your application. So jQuery mobile apparently execute 4,000 functions just to display a simple page. This is not necessarily bad per se because most of the function call is a quick one. But what you want to monitor is how does this number change over the time. So if it's 4,000 something right now, and then a couple of months later it becomes 20,000, then something is suspicious there. So you could totally put this into your CI system and kind of monitor that. Scalability is another issue. Scalability here doesn't always mean scale your architecture, but it also means how would your function work if the data changes. So say you create an address book application, you need to be able to sort all the contacts. If your contact is just 10 or 100, even bubble sort will do it really quickly. So your intern said, hey, I've implemented this address book sorting. It's finished in 10 milliseconds. It's the absolute time to execute a function doesn't mean anything in the context of scalability because you need to test whether your address book can sort 10,000 contacts reasonably well. And the way it works is you can annotate all the function and then you see how the function, the number of calls as a function of the different data. So in this case, in the case of address book sorting, you want to see how many times array swap is called if the context is only 10. If the context is only reached 100 and then 1,000, 10,000 and so on. Because bubble sort can sort 10 addresses rather easily, but when it's like 1,000, then you start to have problem. And you would not notice this by just measuring how long does it take to execute the function. Transformation. So I mentioned about minification, closure compiler, and Uglify.js. That's just one of the use cases of code transformation. I've introduced something that I call I know it's a lot of buzzword, non-destructive partial source modification, which basically means that it will modify your code only on particular parts. So if it doesn't interest the tools, then it will just happily ignore that. One of the obvious non-destructive modification is to change the literal quotes. Who here uses single quote for strings? And double quotes? So if you don't define this or strictly mandate this in your coding style, some guy might use single quote, another guy might use double quotes, and if you want to standardize on certain things, you need to do this non-destructive modification because you just want to change all the quotes. You don't care about anything else. And of course, care must be taken if you change double quoted string that contains double quote, then you need some escaping. Style formatter. So the challenge in formatting style is because sometimes you have to do it manually, and you need to specify typical tools. Say, I want 4 spaces indentation, and I want curly braces in its own line. So one of these tools, Code Painter, does it differently. So you give Code Painter a code that you want it to be. So it's like a sample code, and that's something that Code Painter will read and then deduce what kind of styling do you want. So if your sample has 4 space indentation, then it will assume that you use 4 spaces indentation, and then it will apply it to whatever code that you feed to the tools. So instead of explicitly say to the tools that, hey, I want the curly braces in this place, you just give a sample and then it will deduce it. Same case for quotes, right? If your entire code uses single quote, and then that is given a sample, whenever it encounters double quote, then it will give you a warning. Usually you use single quote, why do you use double quote right now? Rewrite and regenerate. This is possible through syntax code modification. So in this case, I parse the expression, and then I can just change the value of the constant there from 42 to something else, and then I can regenerate the code. And this is exactly what code modification works. So in this particular examples, I can shorten the entire code using this because I don't need to use a very long function arguments as the names. And there's a nice project called Smangle that does all this syntax tree messaging so that the overall execution of the program won't change, but the code itself gets much shorter. There's also something called tree checking, where if you write a lot of code and then you write a function that never gets executed anywhere, then it can remove that because it looks at all the tree and then kind of check it, and then at one point one will drop because it's not being used. Syntax augmentation. So say you're not happy with JavaScript, you want to use something else, and a lot of people use CoffeeScript, there's Dart right now, there's TypeScript, and the way you augment the syntax of JavaScript is through possible scenarios, either adding some new syntax or borrow something from the future. So low-level JavaScript changes the syntax, introduce a bunch of low-level features of JavaScript so that you can use, say, data types. So instead of just opaque variable type, you can define this is 8-bit integers, this is unsigned 32 bits, and so on. This is a Mozilla research project, and if you type this, it will compile to JavaScript. So this is what you type, and the generated code is something that your browser will execute, pretty much like CoffeeScript but different syntax. There's also Sweet.js, another Mozilla project, where you can define a macro and then you can use it later. So in this case, you can create a new syntax for defining function by using def instead of function something. Transpilation. How many of you are familiar with the concept of transpilation? So transpilation, kind of like compilation, but it's called trans because apparently it's just compile some flavor of JavaScript to another flavor of JavaScript. So if it's CoffeeScript, it's completely different, but transpilation is some JavaScript syntax that doesn't exist right now to something that you can use. For example, the next version of ECMAScript, next version of ECMAScript will introduce the concept of class. And of course, you can use it right now because no browser supports class, but you can totally type this and then get it compiled or transpiled to the following contract over there that can be executed by a browser today. And you can use it right now. There's a project to do that. And this is an example of non-destructive source modification, because if you look at the code here, all your comments are still there. So the tools doesn't modify. The transpiler doesn't touch anything that it doesn't care about. So in this case, it only looks for class syntax and then modify that. It doesn't care about anything else. There's a transpiler from Google called Parser, and it does the same, but Parser regenerates the entire code. So if you have comments, if you use four-space indentation, if you use blank lines, everything will be gone. It also has ECMAScript next will support module definitions, so you don't need to use this immediately invoke function expression that is very cryptic for beginners. And again, if I put some line comments there, it will exist in the transpiled version. So if you want to do this, there's a project called Harmonizer, which basically borrows the future. So you can start using Harmony, which is next generation of ECMAScript, by transpiling it into something that can be executed today. Anyone wants class construct in JavaScript? Or everyone is familiar or happy with only object and prototypes? Some people want it. So let's talk about the future. These are all things that you can try right now, and those projects exist, and you can start using it. Code review. So every time someone creates a patch or submit a pull request, we need to go through all the details like, hey, the coding style is wrong, it's not tested this way and this way and this way. With Travis CI, you could totally automate this. You can put in any kind of analysis that you want, right? I mentioned before, what if we automatically check the syntax for a patch, because then you don't need to make sure that it passes the validator. So a lot of things that people do as part of the code review process, that should be automated. And I think that's one of the most ambitious goals for next year, meaning that we should not try to analyze the code manually if you have done this already a couple of times. For example, if if the coding style has to follow certain standard, then rather than checking it by hand, that should be one of the tools that is placed there. Syntax query. So you've seen a simple code linting example where I look for double equal, but I wish that we could define a way, a syntax to look for certain particular construct in your code. For example, using CSS selector as a model. So if I want to find this assignment expression, then I can just type this, and it will immediately give me, oh, use it in this location. And then I can then say to the user, oh, why do you use this operator in a branch condition? You might not want to do that because that's supposed to do assignment. So CSS selector, I'm sure everyone is familiar with CSS selector. Rather than using the DOM API that you have to get the first node and then traverse and then next, you just type simple construct and then it will pick exactly the elements that you want that match that particular criteria. Copy paste mistake. Can someone spot why it's wrong or why the code is wrong? What did I do? Or what I didn't do after I copied?
Didn't get all the X's into Y's.
Yes. And this is a nice example because it's simple and I align the code. So this one is wrong, right? Because it's supposed to, it has to be Y too because it doesn't make sense to put that condition again. So a lot of tools in different programming languages exist to detect that kind of copy paste mistake, and I think it's a matter of time before we have to have that as part of our JavaScript development workflow. This really helps. In particular, again, in the context of code review, because you might look at the patch and because it's 2 a.m. in the night, you will not notice that one is wrong. Refactoring, a lot of, yes? So the question is about how this works. I haven't implemented this, but one of the things that a lot of other tools like in C++ and Java works is based on heuristics. So like in this, if I detect that this is actually conditional for and conditional, and then you have two conditions there, it doesn't make sense. So they're all the same, so something should be different, because otherwise I would not need the second line, right? the last part of the second line. There's also something like code coverage, where, for example, if you create a function and you call it 1,000,000 times and you always check the return value, and one time you don't check the return value, it'll give you warning because, hey, all these years, all these days, you always check the return value of this function. Why don't you do it right now? So there must be something suspicious there. Refactoring Helper, a lot of IDE like WebStorm can do that, and I think if we put a lot of effort, convention standard into those, one day I can just say, I create this backbone router, and then I want to change the name. I don't need to do a search replace because it understands this is the way backbone works. And many more. Semantic diff. If you commit the code and want to check the diff, you do git diff. It gives you like textual diff, which is pretty useless. What I want to see is like, did I just suddenly declare a new variable? What kind of block did I remove? And so on. Syntax error. This is useful for educational purposes because a lot of time, if you write the code and any browser refuses to work, what you get is unexpected token, semicolon. So it doesn't tell you what's wrong there. Why did I make that mistake? So it tells why the syntax doesn't conform to the specification, to the grammar defined in the specification, but it doesn't try to deduce the construct that causes that kind of problem. Symbolic execution is something better than just dynamic analysis. When you write a unit test, you have to define your fixtures by hand, right? So if I create a function that adds two numbers, and then I write the unit test, I have to tell, try to add 1 and 1 and see if it's 2, 2 and 1 and see if it's 3, and so on and so on. Whereas with symbolic execution, it executes your code and then sees that, oh, you have a division operator. Let's try to find a fixture that trigger a divide by 0 and see if your program behaves or not. Declarative transformation, I already mentioned about declarative, what was that? Syntax query, where you can ask, hey, there's an assignment expression in an if conditional, but we also want to have declarative transformation. So I can totally change, hey, you use class syntax from ECMAScript 6 or 7. I want to transform it to something that the browser can execute using Transplation, but not writing any long code for that. And pattern matching. Pattern matching is very useful to detect the copy-paste mistake, because I want to be able to declare if there's an and condition, please check whether there's a similar condition in one of those branches. So all this parsing infrastructure enables a lot of different type of user, anything from tools, anything from modifications to code coverage. And the goal of all these tools, of course, to try to analyze something that no tools can analyze before. And hopefully that will empower new users so that they can make less mistake and then bring a lot of features so that power user or someone that's expert on JavaScript can still be productive writing application with JavaScript. Thank you.